All right, so most of you guys, you should check the graph, but also I want to go through some graphing technique. You need to start bringing calculator in, um, because that's gonna help you for understanding. Um, so apparently I've been streaming for 24 hours. Um, like remind me to turn off my stream after that period. Otherwise, I keep on streaming during the day. So any question about graphing for the first five? Uh, Ben, you had a question? No. Did you check your graph on Desmos? Okay, so now I'm going to talk about check your graph on the Desmos. So, for example, let's just say, can somebody tell me that? Yes. Uh, hold on a second. I'm saying first five. So, give me any random questions. I like to say number three. What's the number three? One half.
Minus 1 squared, x plus 2 to the third.
That's it, right? Okay, so then you can easily find out this is one half x to the fifth, which is limit x approach negative infinity of f of x is equal to negative infinity, limit x approach to positive infinity of f of x equal to positive infinity. Um, then you have y-intercept at where? 0, 4. Okay, so if I plug in 0, and I'm gonna get 4, so it's 0 comma 4. And again, this is a 4. I'm gonna say 4 is right here. 1 here and 2. Um, that says 2, negative 2. So it's probably something like this, something like that. I don't know exactly how the graph goes. And if you want to check on Desmos, you can check it. This is probably not the best one to talk about this, but that's okay. Let's try it. So 1 over 2, parenthesis what? X minus what?
1
X minus 1 square, right? Square or third?
squared.
Okay, so, and then x plus 2 to the third, right? Okay, so yeah, the graph's pretty much it. I mean, those, how far is this graph as opposed to this graph? Um, maybe I needed more like this part of waterfall here. Um, but pretty much is this graph. Now, sometimes you see, I think Ashton, the picture Ashton posted earlier, it's a like the graph is really extended. No. I'm saying that graph is really extended. All you can see like bunch of straight lines. You can readjust that by I don't know which one is that. Do you know which graph it was that?
4, I think.
4? Okay, so can you tell me what graph 4 is?
Um,
What's a function for? What's it?
135.
Oh, 1 over 135.
X plus 3.
X plus 3 cube. X minus 2 square. X minus 2 square. Hold on a second. Square like this.
Yeah.
X minus 5.
the a value is negative.
What?
A value is negative.
A value is negative. Okay. So then if you don't see this, you can readjust this and see are they very similar to this. So you can readjust by the changing the y-axis, y min and y max. Guys, pay attention to this part. So if this part that says if something that's way over like the maximum is like 1,000 something, you can readjust this to like maybe 50, right? You can do this. Is a graph roughly look the same. Probably let's look at here the graph.
Why is it on the bottom side of the x-axis? It goes down to -4.
So this is number 4, right?
Yeah.
Okay, let's look at it. Number 4, it has x cubed. Okay, let's check. Oh yeah, so I think it's positive. I think it's this way. Positive 1 over 135. Let's look at it. Let's check the graph. That one's right. That one's right. That one's right. And that one's right. Yeah, it looks almost like it for number 4. Except this one doesn't. Now let's stretch this maybe to -10. You see it a little bit better. So definitely adjust the y. You can readjust the y to help you. In the calculator setting, it's gonna be x min and y min and y max. You can go to here. You can change the y min and y max. Yes.
Matter if we're placing the y at the y coordinate in our line, will it be marked wrong if we do that, or does it?
That part I don't really care. As long as they intersect the correct y-intercept, I don't really mind. The only thing is I only pay attention to behavior at n, which is n behavior. Also the behavior at x-intercept, and also it doesn't need to have a behavior for the y-intercept because there's no such a way that you go across y. But yeah. Any other questions? Yes.
Where did the 1 over 135?
Where's 1 over 135 come from? Okay, let's go back to the calculations. So at here, we start first one here. It says x. So I usually write down 2 things. So that way it help you what happened today. It's called factor theorem. So this is x equal to -3. X is equal to 2 and x equal to 5. So what I'm going to do is I'm going to go to a factor form. What would be the factor form here? If x equal to -3, what do you think the factor? X plus 3, right? And then this is going to be x minus 2. And this is going to be x minus 5. Is that okay?
Yeah.
So this is the first power because m is equal to 1. It looks like this is a straight line. This is a bounce, so it's probably second, and this is to the third. And then what happened is you're going to have f of x equal to a times x plus 3 to the third times x minus 2 to the second times x minus 5. Aria, pay attention. And then you have a y-intercept, so it's going to be a -4 is equal to 0. A times 0. 0 to the plus 3 to the third is 27. 0 minus 2 is going to be -2 squared. 0 minus 5 is going to be -5. So it'll be -4 over 27 times 4 times -5. So that's equal to equal to a. So 4 and 4 cancel out. I think that's going to be 1 over 135 for a. So just replace that 1 over 135. You get the equation. Because I use a y-intercept. So I use a y-intercept as a key here. If I don't use a y-intercept, imagine like this, right? Imagine that I don't have y-intercept that have similar characteristic of that. You could have a limited amount. So I'm going to show you what I mean by a limited amount. You can have a all the way from, see that a is changing? It could be all the things have similar things right here. But the only one that works is 1 over 135. And that's gonna lock into the situations. Otherwise, it can constantly changing. But only one of them go to y-intercept. Questions? No? Okay. So some people say 10. 10 I might not teach you, but all those you should know how to factor. I always factor out a -1, so that's going to be x4. I don't like the first coefficient to be negative. And now I'm going to factor more. So I use a box method. A lot of you guys don't like the box method, but this question really helps you. So that's going to be x squared, and there's a 4 and 1. There's a 4x squared. There's a 1x squared. Well, one of them need to be negative, so this one need to be negative. So it's going to be this is plus, right? So it'd be negative x squared plus 1 and x squared minus 4. So it turns out there's only two. This is a negative x to the 4. There's only two things that really qualify because this doesn't give you zeros. Because if you do x squared plus 1 equal to 0, x squared equal to -1, x squared equal x equal to square root of -1 plus minus, that's equal to plus minus I. The thing is, I doesn't give you an x-intercept. I give you a things that usually that you have a hard time to see. I will show you a video. Like there was a way to show you the in a complex plane, and it's totally different than the what the usually x and y plane that we see. It's gonna be like it's not something a high school teacher can teach. And so I'm gonna show you something like that in a second. So here it's gonna be -2 and 2, and then you have n behaviors down, and you have 4 is somewhere here. So the only thing is you can graph something like, I don't know how you're gonna graph it, but you find out the graph's probably gonna be something like this. How do you know those two maximum here? You don't. You don't have that ability to see that. Because right now you only can see 2 x-intercept and 1 y-intercept and 2 n behavior. If you graph any sorts of, you can even graph like this. I will probably would give you credit because you have x-intercept, y-intercept, and multiplicity is correct. Because that's the only thing you're able to accomplish. Now, x squared plus 1 is something that is very interesting. But if we got time, I'll probably show you probably like next week. Is x squared plus 1. It's some graph that you cannot see. Like it does go through 0, but it's in a different way. It's not in a real plane. It's in a different plane. It's like a plane that you cannot see. So it's kind of out there. But I'll show you a video to demonstrate that. Okay. So what we're gonna do today is we're gonna keep on going. Factor theorem. Let me see if I can find a question like that. So I'm gonna pull a SAT question out here. Let me see if I can find it. Yeah. I'm trying to find something that, let me see if maybe it's on the first test. Third test. Something about factor theorem. we already doing factor theorem regularly that you don't realize it. Maybe oh, this textbook it's easier. Probably on this test. Okay. So this is number 9. This I want you guys to try number 9. I'm not gonna tell you the answer, but I want you to try for 2 minutes and come up your answer, and I want you to debate with each other. What do you think the answer will be? I'll try, but that's probably the maximum I can go to. So number 9 is a question on the left hand side. Very easy SAT question. You can take a picture of it and zoom in. Maybe. They need to give me a bigger classroom. Astro, I feel like cannot see anything. You cannot see anything because that side?
Yeah.
Oh, that's a problem. Wait, all the stuff I write down you cannot see?
Sometimes when you zoom in, I can see. But when it's like really zoomed out, I can see.
That sucks. That's a problem. Do you think moving the chair back a little bit to this direction that you can see? Yeah, you can move a little bit. Yeah, you can move like perpendicular to Maryland. Do you think that's better? You can move a little bit more. There you go. Just push them, shuffle them to the back. I'm sorry. Number 9, number 11, they both are good question because it is some question that we already talked about, but number 9 is a little bit different. And now you guys can talk to each other. Why do you think your answer is that way? You can talk to each other, not to everybody.
Yeah, so, because when you write it like that, it's x equals -2, and you bring it to minus x plus 2. So then that's how I got 3. And then for 1, it's for 3 zeros. h3 when you bring it to the other side equals sin of x minus.
Julia, can you bring glasses? You just forgot today. Do you guys come to conclusion? What do you think the answer? Huh? B. Okay, so, and you have different answer? Okay, so the thing is about this question, a long time ago, when you see this question, will be a little bit more difficult, right? Now you see this, you can analyzing says, well, I know there is some x-intercept and y-intercept here, and the things that x-intercept is giving is right here. Is right here. Oops, my bad. And so I see here the compensation that was correct. Now the 0, -6 is actually y-intercept. But if this is the x-intercept, that means x equal to -2. But that also means what? X plus 2 is a factor. Does that make sense? So when they equal to 0, it becomes a factor. When they equal to a number, if you move the number to the other side, it becomes a factor. The same thing as x equal to 3 and x minus 3 equal to 0. So it becomes a factor. So x plus 2 and x minus 3. So 1 and 3 only. The answer is B. Yes.
I did another way, but it's still
Which way you did?
I mean, I just looked at which ones multiplied to -6 if you made the x 0. So it would be like 1 and 3.
Yeah, but that's kind of risky because you are risking sometimes if I have technically I can have x minus 3 as a factor and x plus 3 as a factor, x minus 2 is still hold true. Do you see what I'm saying? You're taking that risk of there's a possibility it might not be true. So you are lucky is because there was only, what if I have a fourth choice that's x minus 3, x plus 3? Then you don't know which one to pick. So because they all end up to be 6. If I were to pick a question where I will arrange where that I can, against your intuitive, and then it will definitely hurt you more than hurt other people. So you gotta think about what is the most the best way to prove it. Okay, so another question will be number 11. Number 11 is actually a great question. And the reason why this is a great question is talking about reverse of that. So what do you think the answer for number 11? Jesus, come back to me.
I'm losing it so I'm so sorry.
No, it's okay. You had to come back so I can make fun of you. How about number 11? Do you guys got an answer? I think we did this question, right? On the test. I put it on the test before, right? No? So, what do you guys got answers? Raise your hand if you think. Yeah, Armin? A, -1? Everybody agree? How do you get A?
A because I was looking at that. I was looking at the x list. Oh wait. Oh, it's y. You look at that.
Okay, good. So you think about x minus 4, right? Is equal to 0, right? Because we set y equal to 0, we're looking for the x-intercept. And the x equal to -2 and x equal to 4. Now, the average of two x-intercept is with the axis symmetry. So I can have 4 plus -2 over 2. So SAT exam is not hard. It's just knowing that if you understand that is C. Now, if I were to ask you for y value, then that's going to be kind of hard because we don't know what k is, but we know axis symmetry is right between two x-intercepts. So yeah, so those are the things that you can do. You don't have to know all the clue. You only have to know partial the clue, but my class, I'm going to explain to you all the clue. But you have to figure out what is the best way to approach your questions and other things like that. So now we know that we have a little bit understanding of factor theorem. What is a factor theorem? If so factor theorem basically just saying, I don't know how the word exactly is, but factor theorem says if x equal to a, right, is 0, then x minus a is a factor, right? So those are basically the factor theorem says. Now we're going to implement something called remainder theorem, and we're going to go with remainder theorem and actually to establish proof. But today we're going to talk about rational root, and that's where it's a little bit more complex. So we learn a new way to factor. We learn all the way to factor. For the first 9 weeks, I teach you all different ways. Difference of a square, factor, sum and difference of the cube, factor by grouping, box method, GCF. So we learn 5 different ways to factor something. I'm going to teach you the 6th way. The 6th way, well, there's probably a 6th way we can argue against quadratic formula can be used as a factoring, but I think that's a very crappy way to factoring something. But yeah, you can actually use quadratic, and so you can argue that and the other one, so it doesn't really matter. So let's talk about what is rational root theorem, and then how do we approach that. I don't know if I want to do this question. Okay, let's do this question. So today I want to solve for this. 10x cubed plus 9x squared. Are you serious? Okay, so this one is going to be minus 19x plus 6 equal to 0. So what we're going to do is we're going to take a wild guess about what the possible root is. Because there is no way I can use factor by grouping. If you are good with math, you know there's nothing to factor out if you parentheses first 2 term, parentheses last 2 term. There's no way for you to accomplish that. So what we're gonna do is we're gonna see something called rational roots. So I'm gonna take the rational root theorem. We're gonna take the 10 and the 6. So it's gonna be factor of 10 over factor of 6. So factor of 10. So what's a factor of 10? Well, there's more than that. 1, it's also a factor, right? 2, 5, and 10. What'd you say? Over plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So unfortunately, on the test, I will ask you to write down all the factors. So the factor is going to be, well, the factor is basically a combination of all this. 1, 2, 3, 4, and then 1, 2, 3, 4, and then 1, 2, 3, 4, and then 1, 2, 3, 4. So any kind of combination that you can possibly form, and that's going to be a factor. So I'm going to start with all the integers. So it's going to be plus minus I'm gonna start with the biggest number, plus minus 10, plus minus 5, because you have 10 divided by 1, 5 divided by 1, 2 divided by 1, right? And then 1. So that's the first one. The second one is 10 divided by 2 is repeated. So I'm gonna match up this one with all of them, right? So 10 divided by 2 is 5. 5 divided by 2 is new. Do you see that? And 2 divided by 2 is repeated because plus minus 1 is over there. And the plus minus half. And then that, I'm going to go to the third possibility. The third possibility is 3. So it's going to be, now this one might have all of them, 10 over 3, plus minus, and then plus minus 5 over 3, plus minus 2 over 3, and then plus minus what? 1 over 3. Does that make sense? I write down all the combination I can possibly have. The last one is a 6. Everything's going to divide by 6. So it's going to be 10 divided by 6 is 5 over 3, which is, you already see here, 5 over 3. We don't need to write down. 5 over 6, yes. 2 over 6 is 1 over 3. It's already repeated. And then 1 over 6. So I basically match all of them. And I go to the second one, I match all of them. I see any repeating, I don't write it down. I just write down whatever's needed. So total they have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, 22 possible combinations. Yes.
Wait, so the reason why you didn't write down is that you divided 10 by 2. You didn't write down 5 because it was already in the original.
Yep.
Divided by 1.
Yeah, I divide by 1, I just do plus minus 10, plus minus 5, plus minus 2, plus minus 1. What? Yeah, well, yeah, because you divide by 1 still is 1. It doesn't matter. So let's call rational root theorem. I'm going to ask you to write down all the rational root on the test. Probably not much combination to this. So your roots, your 0 could be any of those number. Now the thing is, do you want to try all those number? The thing is no. Here's the key. On the test, you should start with 1 or -1, or 2 and -2. You should start with those easy numbers, like 1 or 2s and 2 and 2s and whatever. Okay, so I'm going to start with the 1. And you're going to find out the goal is to do synthetic division, and hopefully they get a 0, because if it's a 0, it's a factor. Does that make sense? So I'm going to do 10, 9, -19, and 6. And hopefully they come out to be the 1. So 10. 10 times 1 is what? 10, 19. This is 19. This is 0. 0 times 1 is 1, 7. So the remainder is not 0. And you're like, okay, so it's not a factor, right? Oh, sorry, I can multiply. My bad. But regardless, it's still not 0. Okay, what's the next number you want to try? Between 1, -1, 2, and -2. Which one number you want to try? 2. Okay, let's go with 2. So 2, let's see how lucky you are. Because one of them is answer. I don't want to tell you which one. So it's 10. But it doesn't take a long time to do synthetic division. 29, 58, 37, I believe. I'm not sure. Yeah, it's 37. No, 39, right? I can't multiply. It's 39. 39 times 2 is 78. And that's 84. It's not 0. like shit. What's the next number you want to try? Let's pick a number. Come on. -1. Okay. -1's 10, 9, -19, 6, and 10. -1 is -10. -1. -1 times 1 is 1. -18. 18, so it's 24. Garbage. Okay, so you guys have really shitty luck because the answer is -2. And now hopefully that worked, right? So on the test is really gonna have 1 out of 4 chances. See what's you're gonna take your chances. But first 4 should get you one of the answers. So that's gonna be 10, -20. Hopefully this one is a 1. This one is gonna be what? 22, right? And that's gonna be 3. 3 times -2 is what? -6, 0. Yes. So that means if -2 is equal to 0, right? Is a 0. What is a factor? X plus 2. Now, what is the remainder if you divide it by x plus 2? No. Right? If you divide it by x plus 2, the result should be 10x squared minus 11x plus 3. Is that okay? Why? Because this becomes this. We had 2 per 1 though. Yes.
Explain again why you got 1, 2, -1, -2.
Because they are part of it. So I just always pick the easiest one. And I will tell you on the test, I'm going to pick the easiest one. It depends on your luck. 1 out of 4 chances. Otherwise, you're going to spend extra 2 minutes. So depending on if you feel lucky on that test day or not. Maybe it's a 1. Maybe I play the reverse psychology. Then end up the last number you try is 1. So okay, so now what do I do with the rest? How do I find the rest of the zeros? I have 1 zeros here. Can I just factor this? So that's going to be, well, 10x squared, 3, -11x. And that's 5 and 2, 5x and 2x, sorry, 5x and 2x. And do maybe 3 and 1. No, 3 and 1 doesn't work, right? 15, no. 1 and 3 works. So 1 and 3, so that's gonna be -5x, -6x, because this one add up to be -11. So they're both negative. So pair diagonally. So x plus 2 times 5x minus 3 times 2x minus 1 is equal to 0. I can find in all the zeros, and I actually kind of can graph it. And there we go, this factor theorem for you. So here's a question for you. I don't know if we have enough time. So let's see if you can find all the zeros here. Obviously, factor by grouping is not working. Let's see if you feel lucky. And also be able to write down all the roots. Murray, what'd you say? You so lost, or?
No, it's because I was gonna pick -2. That was my first choice, and I just didn't say anything.
Oh, you should have said anything, because you wasted me 3 tries. Armin? Yeah, but no, it's just the way they will test it. They will test you like what's a possible zero, are they? Now, if you realize, see, this is 1/2. Let's go back. 1/2. 1/2 is in here, and 3/5 is also there, I believe. Is there? No, it's not there. 5/3. There's no 3/5. So even most of the time it doesn't work. -2 is there for sure. They just say possible roots. And it's not guaranteed like it's always there. But yeah, so apparently one of them, two of them's there out of three. And but the easiest one for me, I'm not gonna ask you to try 2/3. That's a lot of number to try. There was 22 possibility here. And I'm gonna say general rule of thumb is try 1, 2, and -1 and -2 and see how lucky you are. So let's see how lucky you are here.
You do. There's a fold in it.
Or you can split up the work. Say you try 1, you try 2. But you end up that the other factor is gonna be different. So you're gonna have to factor the other one anyway. Jealous, good luck. You went to all of them? You should not go to the casino.
Choose like the first and last.
Yeah, so for rational root, you have to try the first and last, and the factor of the constant over the factor of the bottom. So factor of 8 over factor of 3. Now this one has a little bit less combination. Actually, do they? Yeah, I do have less combinations. So it has plus minus 1, plus minus 2, plus minus 4, plus minus 8, and then plus minus 1 over third, plus minus 2 over third, plus minus 4 over third, plus minus 8 over third. So those are the rational roots. Feel lucky today? First try? Second try, okay.
And it was good.
Huh? Factor what? Oh, it's always the other way. It's always the constant over leading coefficient.
The leading coefficient.
What?
We did that.
Oh, did I do it wrong? Hold on a second. No. Yeah, it's constant. Oh, did I do it wrong first time? Oh, my fault. I'm so sorry. I screwed up here because I screwed up here. This one. Can you go back to change this? This one's factor of 6 over factor of 10. So it should be reversed. So all the numbers in reverse. I'm so sorry. So that is gonna be plus minus 1, plus minus 2, plus minus 3, plus minus 6 over. Okay, so this should be all the combination here. I'm so sorry, I messed up here. I write the number wrong. Huh? Yeah, you can swap them if you want. It's A14. The bell's not working. Did you find all 3 factors? Okay. Today's homework is gonna be our factor out 3 and then graph it.
No, right down.
Huh? Oh, okay.
How did you get 10x minus 11x?
Because this part, the left over here, the left over here,
Okay.
and because this is 0, then you can use this.
Okay.
If it's not 0, you can use it. What?
Instead of joining the factors.
Yeah, but the point of that is also get this at the same time. Because if you just plug in 1 or -1, it doesn't really work. Because this is what you're trying to get because you want to factor the rest. So you want to get this to get to here, and then factor the rest.
But you already factored it. Like I just canceled my third choice. Like I put a 2. Like I would just go to 1, -1, 2. And I just
Yeah, but this one is hard because -1, 1/2, and 3/5 is not easy to get.
Oh.
So
All the fraction stuff we did with like the way you did the 6/10 thing. Do you have to know that for the 10th, or can we just do the 1, -1, 2, -2?
you have to know that, unfortunately, because that's part of AP then. But you have to know how to write it up.
Was this streamed or not?
Yeah, it was streamed, but you have to go back and change this one. Let me fix this one before everything. So there's a +/-1, +/-2, +/-3, +/-6, +/-1/2, +/-1, 3/2. 3 is there. 1/5, 2/5, 3/5, and 6/5, and 1/10. 1/5 is already there. 3/10, and 3/5. Yep, it's already. So correct version.
Thank you.
No, I'm gonna end the stream now.
Yeah, obviously.
The problem with that is they can actually do that, but the problem is